Alright, so we're going to do a little bit of review of what we did last time. And we're going to talk about a couple new things today. Last time in class we talked about writing the equation of a line in slope-intercept form. Remember, if you don't remember, down here at the bottom there's a little reminder. Slope-intercept form is y equals mx plus b. And to write an equation in slope-intercept form, you would have to have the m and the b, the slope and the y-intercept. Thus the reason it's called slope-intercept form. So if you take a look at this equation up here, you can see that the graph crosses through the y-axis at 6. The reason I got that was I just counted up to 6. 0 for x value, 6 for the y value. Then I notice that it passes through this point here. So if I look and it goes from this point down to this point, number one, I should know that my slope is going to be negative. The next thing I need to be able to do is be able to count. Notice this one goes down 3 spaces and over 5. So that would be down 3 over 5. In other words, negative 3/5 is my slope. You could also use your calculator to figure out that that is negative 0.6 if you needed a decimal. But changing it back to a fraction, it still tells you that that is also the reduced form of that fraction. So that's my m, that's my slope. What's my b again? Well, that first point I found. That first point was the y-intercept. The b is the intercept in slope-intercept form. So it is 6. So if I have my m and I have my b, then all I have to do to write my equation is write y equals mx plus b. Now if that b was negative, you would have a minus there. If the slope was positive, it would be positive. Just make sure that your slope matches up with what your line is doing. It's going down 3 over 5. And make sure your y-intercept matches up with where your actual y-intercept is, where it crosses the y-axis. Now we also talked about last time in class, and I'm not going to do any specific review problems, but we talked about last time in class how the m and the b can be given to you in a problem, just handed to you, or in a real-life applications problem, you may have to kind of search for them a little bit. The b would be the beginning amount. The m would be the slope, what you move by. But also you can think about that as the rate of change in a real-world application. So today we're going to be taking a look at different amounts of information given to you in the problem. In the first lesson, we learned how to write an equation of a line if we were given the slope and given the y-intercept of the line. You just use slope-intercept form, plugged it in for m, and plugged it in for b, your slope and your y-intercept. In this lesson, you're going to learn to write an equation of a line when you are given its slope and any other point on the line, not the y-intercept. Although you could use this if you had the y-intercept, that's not needed if you are given the y-intercept. So this is when you have a slope and a point somewhere on the line. The way the problem is going to look in a basic idea would be one like this one. Remember that throughout this video you can always pause the video and stop it if you need to. Write an equation of the line that passes through the point 6, negative 3 and has a slope of negative 2. So as soon as you see that first part, write an equation of the line. You should immediately be thinking y equals mx plus b. I need my m, I need my b. So just like the other problems the other day, it's the same things we're looking for. We're not looking for something different. It doesn't change just because, oh no, he's changed what information he gave us. It doesn't change what you do. You still are looking for the slope and the y-intercept. So what is given to you in the problem? Take a second to look at it and notice the last part of the sentence. The slope is -2. So we are given the slope, -2. But we are not given the b. Now some of you may say, yeah, we are, it's -3. No, look at it again. It's 6, -3. Now if you think about a graph, and you go out to 6, -3, that's going to be down in this region here, in the fourth quadrant. That is not the y-intercept. The y-intercept has to be somewhere on the y-axis. This is not on the y-axis. So, we need to find the b. What we are given here is 6 and -3 for our x value and our y value from another random point on the line. I'm going to show you 2 different ways that you can do this problem. I'm going to show you 2 different ways that you can approach it. Alright, so the first method that I'm going to teach you is the one that most of you will probably choose every time that you are doing this process, and that's completely fine because it works very, very well. This method is using the slope-intercept form again. Y equals mx plus b. What you basically do is you take what you know, you plug it in to find what you don't know. So you have m is -2. So you have -2. You know an x value of 6 from the point that you had. You know that the y value is -3 from the point that you had. And you do not know what b is. So you solve this equation, meaning you find what b is. So what is -2 times 6? It's -12. So I have -12 plus b is equal to -3. How do I get b by itself to find what b is? I add 12 to both sides. So I add 12 to this side, and I add 12 to this side. What is -3 plus 12? 9. So now what I just found is I just found my b value. Now I know my m is -2, my b is 9, so my equation would be y equals -2x plus 9, just like we did last time in class. The difference here again is that you had to find your b using a separate point on the graph. The other option is to use something called the point slope form. Remember, you can pause this video if you need to write down any notes. Notes are good. They help you out a lot, don't they? This point slope form is kind of ugly. This is why most of you will not choose this form. But you can use it. It's nice because it tells you when you should use it. It's called the point slope form, so you use it when you have a point and a slope. Point slope form is basically the same idea as what you did with slope-intercept form. You plug in the y value from the point, which would be -3. You plug in the m, the slope, -2. And then you plug in the x value from the point, 6. Notice this y and this x, I'm going to highlight them here. This y and this x are variables, because when you finish this form, you will actually have your equation staring you in the face. It's a little different from slope-intercept form, where you actually had to take the b and plug it into your equation. So this is actually minus a negative, so that is plus 3. Remember, negative times a negative is a positive. Over here, you distribute the negative 2 times x is negative 2x. Guys, think about it. That's your slope. It'll always be beside x. Negative 2 times negative 6 is positive 12. Notice you're doing the same amount of math that you did over here with multiplying. And then you're going to take this and get rid of the plus 3 by subtracting 3 on this side. And what you do to one side, you got to do to the other. So you subtract 3 on this side. That gives me y equals negative 2x plus 9. Notice your answer is exactly the same. You can use either one of these methods when you have a point and a slope. I personally prefer the point-slope form because it's called point-slope form. You use it when you have a point, a slope. But many of you don't like to learn new formulas, and so you may use the y equals mx plus b over and over again. Just don't forget to take your b value and actually plug it into your equation. The goal is to do exactly like we did a couple of classes ago, or last class, excuse me, is to get your y equals mx plus b with your m and your b. You just have to find your b in this case. If you would like to have some steps, this is what I'm doing. First, I'm finding the y-intercept. I'm doing this by substituting the slope and the coordinates from the point into the slope-intercept form, or you can use the point-slope form, and I'm solving for b. Then I write my equation of my line. So take a look at this example. It says two non-vertical lines are parallel if and only if they have the same slope. So write an equation of a line. Again, your head should be saying, y equals mx plus b. I need to find my m and my b to write my equation. Notice, though, this one says write an equation of a line that is parallel to this line and passes through the point negative 2, 1. Now, compared to what we just did, negative 2, 1 is a point on the line, but it's not the y-intercept, so I don't know the y-intercept. And it's parallel to this line, which means I don't have the slope. Or do I? What did it say before? Two lines are parallel if and only if they have the same slope. So when I tell you that something is parallel, I'm telling you that it has the same slope. So 2/3 is my slope. Now 2/3 is a fraction, and that means it's going to be kind of ugly, but I can still find my equation of my line in two different ways. I can use the slope-intercept form, or I can use what Mr. Harrison also showed me called the point-slope form. So I'm going to show you both ways again. I'm probably not going to do this on every single problem in this video, but we'll see if I have time. So I plug in what I know. 2/3 is the slope. Negative 2 is the x value. 1 is the y value. And then I can find my b. Now it is an ugly fraction here, so I am going to do a little bit of math in my head for you. But you can always go through and use a calculator if you need to. Just saving a little bit of time in this video. So negative 2 times 2/3 would end up being negative 4/3 because you multiply negative 2 times 2. Then you have to take negative 4/3 and move it over to the other side by adding 4/3 to this side and adding 4/3 to this side. So you take 4/3 and 1 and add them together. Again, you can use your calculator, but that ends up giving you 7/3. That means my equation would be y equals 2/3 x plus 7/3. So, again, when I use the point slope form, I should get the same exact answer. I just have to remember on this one to plug in my b. On this one, my equation will just be staring at me when I'm done. So let's go through the point slope form. Y minus, and then plug in the y value of 1, just like we did over here. 2/3 is my slope, just like we did over here. X minus the x value. Now this is -2. So if I have x minus -2, I am going to have to remember there that that actually becomes x plus 2. That's kind of tricky sometimes for some people, but some people will actually do that in their head before they even write it down. They know they're going to have minus a negative, so they go ahead and put plus. That is fine with me, as long as you understand why you're doing that. If you don't understand why, then you need to write it out. So then I distribute 2/3 times x is 2/3 x. Again, that's my slope. It should be beside x. 2/3 times 2 is 4/3. Then you have minus 1 over here beside the y, but I want it to be on the other side, so I add 1 to get y by itself. It cancels out and leaves me with y equals, again, that's what I'm looking for, 2/3 x, and then I've got my b now. 4/3 plus 1 is 7/3. It's the same equation. Either way you do it. No different. Alright, so now we're going to take a look at a word problem that requires you to do the same process that we've just been talking about with non-word problems. Between 1985 and 1995, the number of vacation trips in the United States taken by United States residents increased by about 26 million per year. We talked about this last time in class, but notice that it says increased 26 million per year. That right there is the same thing as my slope. Remember, the slope is called the rate of change. So, now I'm just looking for my beginning amount. So it says in 1993, United States residents went on 740 million vacation trips within the United States. Is that my beginning amount, 740? No. In 1993, this is how many trips were taken. 1985 is the beginning. Notice it also says down here, we're going to let t, or in our case, we're going to use x, be the number of years since 1985. This is the beginning year, so that's not the beginning amount. So that is my other point, just like I had on this problem, just like I had on this problem. So, since 1985 is the beginning year, 1993 is how many years later? 8 years later. 740 million trips. Notice because I'm using 1985 as the beginning, I don't actually have to plug in 1993 right here. Technically I could, but that would be making the year 0 before there was even a United States, in case you're up on your history, right? The year 0 would be the beginning year. Since we want 1985 to be the beginning, we put 8 for 1993. Now I have my M, I don't have my B, and I have another point. So then I can use either the slope-intercept form or the point-slope form. I'm going to go through real quickly and show you the slope-intercept form, and then you can go back if you would like. I'm going to go through and just write down the steps for the point-slope form. So I'm going to do the slope-intercept form and talk about it. So I know my M is 26. I know that my X value from my point is 8. I know that my Y value from my point is 740, but I don't know b, so that's what I'm trying to find. So I multiply 26 times 8. 26 times 8 is going to be 208. You can use a calculator if you need to. To save a little bit of time, I'm going to write this slightly different here. I'm going to subtract my 208 from both sides. When I subtract 208, 740 minus 208 is going to be 532. Now what does 532 really stand for? It's my beginning amount. That is my b value. But that is also, in real life problem here, the number of vacation trips, 532 million trips in 1985. That's what it really means. So my equation should be 26x plus 532. That's my equation. Part B says to use this equation to estimate the number of vacation trips in the year 2005. 2005 is 20 years after 1985. 1985 to 2005. So 20 years is what I would actually plug in. I'm going to use a slightly different color here. I'm plugging in 20 for the number of years. If I knew what the vacation trips was and I wanted to find how many years, I would plug it in for y and find x. But since I know the year, I plug it in for x to find y, the vacation trips. So you multiply this in your calculator, add it to 532, excuse me. And when you multiply this and add that there, that ends up being 1052, if I'm not mistaken there. Sorry, I was just trying to do the math in my head real quick. Didn't have my calculator open on here. But that should be right, 1052. Now, that's 1052 million trips. Now, is it okay to write it as 1052 million? Yeah. Sometimes you might see it written as 1.052 billion trips, because 1,000 million is a billion. Would this equation be appropriate to use for this question in 2005? Notice that it was between 1985 and 1995 that the number of trips was expected to increase by this much. So 2005 is outside of that range of numbers and years. In math, we call that linear extrapolation. We've gone outside the boundaries of where our equation is actually accurate, and we're going into a guess, an estimate here. It's not going to be a really good one because the number of trips could have changed here. 26 million per year may not be the current rate. This is the danger of looking into the past and assuming that the rate is always going to be the same or has always been the same. This is something that you need to think about when you look at science. When they tell you that the rate of something decaying in science gives you the date of a rock. Mathematically, that's an issue. So, make sure that you take a look at this and realize that 2005 is really outside of that range of numbers. It's kind of outside of that and not a good idea to use this equation for that. Plus, think about in 2001, there was a major event that happened September 11th that caused a lot of traveling to take a downturn for a while. So this definitely could be an inflated number. Again, I'm going to write down the point slope form here for you. and show you what it looks like, but I'm not going to explain every single step just to save a little bit of time. So I'm going to do that real quickly here, and I'm probably not going to talk while I do the rest of it, so make sure I don't mess something up here. One thing I will point out here is that when you are doing the slope-intercept form or the point-slope form, both of them does contain the same amount of math steps. You're multiplying 26, you're multiplying 26. You're subtracting 208 from 740, you're adding 740 to negative 208. It's the same amount of math. I prefer this one because my equation is kind of staring me in the face when I'm done. Alright, here's one more for you to try here on your own. We'll probably do this one in class together next time I see you, so that's why I'm going to hold off on actually doing this one. So try it on your own, put it into your own notes. Alright, so the final type that we are going to look at is writing a linear equation when you are given 2 points. So far in this chapter, you've been writing linear equations which you were given the slope, or the rate of change, and you have been given the y-intercept, or possibly another point. In this lesson, we're going to work with problems which we first have to find the slope. To do this, you've got the same old formula that you've been using previously in all the other parts of the previous chapters. The y2 minus y1 over x2 minus x1. So the way these problems look is like this one right here. Write an equation of a line. Immediately, again, your brain should immediately say, oh yeah, y equals mx plus b. I need to find m, and I need to find b. Here's the problem. If you read the rest of it, it says, write the equation of the line that passes through the points 1, 6, and 3, negative 4. It doesn't give me m. It doesn't give me b. But you do the exact same thing that we did in the previous chapter. You can find the m. You can do y2 minus y1 over x2 minus x1. What is negative 4 minus 6? Negative 10. What is 3 minus 1? 2. Negative 10 divided by 2 is negative 5. Notice, again, now I have my slope, but I don't have my y-intercept still. 1, 6 is not the y-intercept. 3, negative 4 is not the y-intercept. You could plot those points and see that. So what do? I do the same thing that we've been doing over here. If I have a point and a slope, a point and a slope, a point and a slope, I do the same thing. I have 2 points. I can choose whichever one I want, and I have a slope. So I don't care which one you choose. I'm going to show you that both points give you the same answer. For the sake of space on the page here, I'm going to use y equals mx plus b because I figure that's probably the one that most of you are using. And I'm going to plug in my y value from 1, 6. This point first. My slope is negative 5. My x value is 1. And I do not know what b is. So I use this equation to figure it out. Guys, this is an essential skill in math. being able to plug in what you know to find what you don't know. What is negative 5 times 1? It's negative 5. What do I do to get negative 5 over to this side? I add 5. To save a little bit of time here, I'm going to add the 5 over here, just right beside it real quick. That gives me 11 is my p-value. Y equals, what's my slope again? Negative 5x. What's my b-value again? Plus 11. Guys, notice again, and I haven't mentioned this yet, but that last step that I just did is exactly the same thing that we did last class when I gave you the m and I gave you the b and you plugged them in. This one you just had to find. So the same thing happens even if you use the other point. Even if you use 3, negative 4, you can plug in negative 4 for y. Your slope is still negative 5 no matter what. Plug in 3 for x. And don't plug in anything for b. Find b. Negative 5 times 3 is negative 15. How do I get negative 15 over to the other side? I add 15. When I do negative 4 plus 15, I get 11. Again, that makes my equation y equals my slope of negative 5 and my b, my y-intercept of 11. Either way, same answer. So here's your steps if you would like to have some steps written down. You find the slope. If you're given 2 points, you use your 2 points and use the slope formula, y2 minus y1 over x2 minus x1. Then you find your y-intercept. You can use the slope and one of the points in slope-intercept form, or you could also use point-slope form if you would like. I don't care. I prefer this one, but you can use slope-intercept form. Then you write the equation of the line, making sure you've got your slope and your y-intercept that you just found. So, let's take a look at what this would look like in a situation of a word problem and a applications to real life problem. While working in an archaeological dig, you find an upper leg bone, which is called the femur, that belonged to an adult human male. The bone is 43 centimeters long. In humans, femur length is linearly related to height. There's your big clue, linear. To estimate the height of the person, you measure the femur and the height of 2 complete adult male skeletons. So you found just this guy's femur. You measure these 2 people, their complete skeleton, to find how tall this guy is. So you're going to use these 2 skeletons found at the same excavation site, person number 1 and person number 2, to use this information to write an equation that can be used to estimate the height of this guy. So you use what you know to find something you don't know. Notice that this is almost perfectly set up here as 2 points. Only thing being is you got some measurements in there. How do I know that this is going to be my x's and this is going to be my y's in 2 separate points here? We have the point 40, 162, and the point 45, 173. Well, this goes back to something that you talked about in algebra, and we talked about it earlier this year in my class, when we talked about the dependent variable being the y values and the independent variable being the x values. The dependent variable depends on the other one. And I think we all can agree that the height depends on the femur. So, what we're going to do is the same thing we did in the last problem. We're going to find the slope. y2 minus y1 over x2 minus x1. I'm going to show you that again. y2 minus y1. x2 minus x1. So what's 173 minus 162? 11. What is 45 minus 40? 5. That fraction does not reduce, but it also does have a nice decimal, and either one of these would probably be okay for the slope because we are talking about centimeters here. This right here would literally mean, because the heights are on the top and the femurs are on the bottom, that a person gains 2.2 centimeters in height for each centimeter they gain in femur. That's the linear relationship. So now, I want to find my b value so I can write my equation. So I take this slope, 2.2, or I can use 11/5, and I use my points. Pick a point and find my b. Again, for sake of room on the page, I am going to use y equals mx plus b. Actually, I take that back. I'm going to use the point slope on this one, since I used y equals mx plus b on the other one. I'm going to do y minus, and I'm going to plug in 162 for my y value. Remember, that's because the point slope form is y minus y1 equals m times x minus x1. So I'm going to plug in my m, 2.2. Again, 11/5 would be okay here. Just 2.2 is also okay because we're talking about centimeters and height. It's okay to use a decimal there. Just don't use a decimal that you have to round too much right there. And then I do x minus the x value from the point is 40. I distribute 2.2 times x. Again, that's my slope, so it should be beside x. 2.2 times 40. If you use your calculator, it's going to tell you that's negative 88. And then I add the 162 on this side. And I add the 162 on this side, because that will cancel out here and leave me with y equals 2.2x, and then over here on this side plus 74. Now, this is going to be kind of a weird number here, because that beginning amount means if I plugged in 0 for x, that means literally if I had a 0 for a femur, no femur, I'd be 74 centimeters tall. Now, while that might possibly be true, we probably are not going to be talking really about somebody's height if they don't have that femur. And that's probably going to be some major issues going on. But that's what that means. Remember, though, we talked about this on the problem earlier, that this 43 centimeters that we're about to find is okay to plug into here. But 0 is outside of these two people here being my two endpoints that I used. If I really wanted to have a better equation, it would probably be better for me to have a bunch of skeletons found at the same excavation site and make something that we're going to talk about later in the chapter that some of you guys have maybe seen before, where you have a scatter plot and you've got a line that fits through the points. Now, obviously, Mr. Harrison didn't draw a very good line there, but you guys got my idea, right? That is going to be something we talk about later. When you're looking at data points, sometimes it helps to have a whole lot more. So the last thing is to actually use my equation. So I made this equation from person 1 and person 2. Now I want to take this equation and use it to find how tall this guy is. Remember, that was my goal all along, was to come up with a way to figure out how tall this guy is. So I plug 43 in for x. So I take out my calculator and I do 2.2 times 43 plus 74. Now, I'm going to forget this one. I thought I had this one memorized, but I think it's 168.5 0.6, if I'm not mistaken, centimeters tall. That's how tall this guy is right here. Forgive me if this math is wrong. You can use a calculator to figure it out. But here's the point. We took this guy that we didn't know how tall he was. We took two people from the same site because they're very similar to him probably if they're at the same archaeological site. Probably. Don't know for sure. We used their centimeters or their finger and their height, made an equation by finding the slope, finding the b, just like we've been doing on all the other pages. But then we used our equation to figure out how tall this guy was. I think if you think about it a little bit, you can probably come up with some other real-life examples where this could be used. Think about forensic science, finding a body. Think about, crime scene investigation. If somebody goes and steals a calculator from Mr. Harrison and falls out in the snowy ground and leaves the imprint of their finger, or goes through and falls into the mud and leaves an imprint of their finger or some other part of their body, you could figure out a lot about somebody about using imprints from their body and things. So, we'll probably do a couple more examples of these later in class. But, guys, if you need to, you can go back and watch the video again, and you can pause, rewind, try the problems before I go through them. It's always a good idea. So, hope you enjoyed your day off. There will be an assignment on Schoology, a homework assignment. Also probably going to do a little quick, little quiz if I can get it to work correctly. So, see you later.